This is AP Calculus AB Worksheet 1-3, horizontal and vertical asymptotes. All right, I'm reading the directions. For the front side, we're evaluating each limit to infinity. On the back side, we are finding vertical asymptotes, horizontal asymptotes, and providing evidence for those reasonings. All right, so I just kind of plug in infinity, right? You're doing your top-bottom rules. You check the power of the top is 0, the power of the bottom is 2. When the power of the bottom is bigger than the power on the top, the answer is always 0. Again, I'm just checking the powers. Power of 2, power of 1. 2 beats a 1, therefore this is a does not exist. Checking the highest power is 2, the highest power is 1. 2 is bigger, therefore this is a does not exist. And really what I should be doing is I should be crossing out everything that is insignificant on all of these, because you only care about the highest degree. All right, number 4, I'm crossing out lower degrees, crossing out lower degrees, crossing out lower degrees. So what do I notice here? The bottom is an x squared, the top is an x, the bottom wins. I know I'm going to negative infinity in this case, but it does not matter. This is still 0. Over here, I'm looking at the top power, crossing out all the things that are too small of powers. So really I have an x cubed over an x. That means the top wins. This is a does not exist. And number 6, it's a little bit tricky because this one is factored for us, so we need to multiply through. However, I can still use this trick of ignoring things that are small. I can cross out this -1, cross out this 3, cross out this -1, cross out this +3, and then I can multiply through. This is very, very similar to this new problem of the limit as x approaches negative infinity of 2x times negative x all over x times x, which is just negative 2x squared in the numerator and x squared in the denominator. And notice, for the first time in this worksheet, we have a tie, x squared on the top, x squared on the bottom. So whenever there's a tie, that's a magic fraction, and I look at the coefficients, -2 and 1. -2 over 1 is the same thing as -2. All right, in number 7, I'm crossing off all the smaller powers, cross off the smaller powers, and I see that the top wins. When the top wins, that's a does not exist. When I'm looking at number 8, crossing out the smaller degrees, and oh, look at this. I have x squared and x squared, so this is a magic fraction. I take the coefficients. The coefficient here is a +1. The coefficient down here is a -1, so really I have a +1 over a -1, which is equal to a -1. All right, and number 9, again, there's a tie. I can cross off things that are smaller powers, and this is going to be x over x, so coefficient is going to be 1 over 1, which is just 1. In number 10, I cross off all the smaller powers, and again, I have a tie, x squared and x squared, so it's a magic fraction. Take a look at the coefficients. The coefficients are 3 and 4, so our answer is 3/4. In number 11, I cross off all the smaller powers, and I'm left with an x squared and x to the power 4. Whenever the bottom power is bigger, the denominator is bigger, this is a 0. In number 12, again, we need to multiply straight through, so I can cross off the smaller powers before I multiply through. When I multiply through, I'm left with a 20x in the numerator and an x squared in the denominator. Notice x squared is a higher degree than x, therefore this one is a 0. In number 13, I have a tie. The -9 and +3 are gone. Whenever there's a tie, it's a magic fraction. I look at the coefficients 7 and 4, and the answer here is 7/4. In number 14, cross off the smaller powers, and I have an x squared and x squared. There's a tie, so I look at the coefficients, a +7, a +3. This is a +7/3. And you've seen it before, but it does not matter if you're positive or negative infinity. Number 15, cross off the smaller degrees, Notice we have a tie of an x and an x. Those are both degree 1. And I take the coefficients 7 and 3, and I get, again, 7/3, which is very, very similar to the last problem. All right, number 16. I'm looking at the degrees. This degree is too small, and I have a tie. I have an x squared and x squared. Don't forget the negative for the coefficient. I have a -9 and a +4. That is a -9/4. In number 17, cross off the lower degree terms, cross and cross, and the top wins. X squared is a larger degree than the x, so this one is a does not exist. And in number 18, oh no, there's no fraction, Mr. Sindel. Really, there is a fraction. Here it is. So there's a bar, there's a 1 on the bottom. The degree of the top, cross off all the smaller things, cross off all the smaller things. It's a degree 2 versus a degree 0. This is a does not exist because the top is a larger degree. All right. In number 19, just a review, we're finding all the VAs, so vertical asymptotes, I call those my VAs, and my horizontal asymptotes, which I call my HAs, and provide evidence. So let's do that. I always like starting with the horizontal asymptotes because those are the limits to infinity that I just was practicing. So practice writing. To find your horizontal asymptotes, you always take the limit as x approaches infinity. I know it's pedantic. I know you have to write this over and over again. This is to train your mind that horizontal asymptotes are deeply linked with limits to infinity. If you take the limit of f of x as x approaches infinity, you apply your top-bottom rules here. Notice that the top has a degree 1 term, the bottom has a degree 2 term, and this is equal to 0. So truly, what's going on here is a horizontal asymptote is a horizontal line, and that's like a y equals whatever that number is. So it's y equals 0 is the horizontal asymptote. I like writing that down and boxing it so that the person that's grading can see, oh yes, they clearly know that it's a horizontal line for the asymptote. To find the vertical asymptote, what we do is we look at the denominator. So I'm going to rewrite the denominator, x squared plus 5x plus 6, and I just set it equal to 0. Set the bottom equal to 0, you will find all the VAs. Maybe. I'm realizing that's not exactly true though, is it? I really want to factor. So let me back up here. This is jumping the gun. I really need to factor this thing before I move too far. The top stays x minus 1. The bottom, I'm doing a ninja star in my head, and I'm saying, okay, what times what is 6? 1 and 6 don't add up to 5. 2 and 3 add up to 5. So this is x plus 2 and x plus 3. And I was worried, like, if I had an x minus 1 right here and they canceled out, only this one would be the vertical asymptote. But because nothing cancels out, these two stay on the bottom, then I can rewrite that bottom in factor form. I can say this is x plus 2 times x plus 3, set that bottom equal to 0, and using the zero product property, I'll show all my work on number 19, but I'll skip over it in future problems. I can say that x plus 2 is equal to 0 or x plus 3 is equal to 0. Both of those are valid solutions because if this is 0, that doesn't matter what's over there. If this is 0, it doesn't matter what's over there. So subtract 2 on both sides, x is equal to -2 and x is equal to -3. Those are both our VAs. They're vertical asymptotes. All right, moving on to number 20. So I'm going to find the horizontal asymptote first. Again, practice writing. It's the limit of g of x as x approaches infinity. Or you could write negative infinity if you're being cheeky. And when you do that, you look at your top bottom rules. You say, okay, that's small, who wins? 3 versus 2, the top wins. So this is a does not exist. The way that you interpret that is there are no HAs in this problem. So that's what I'll box because we're doing an analysis now. To find my vertical asymptotes, I first need to factor. In the top, I can factor out the greatest common factor. I can divide both of those terms by an x squared. What's left over is an x minus 4. In the denominator, what can I factor out? This is a ninja star problem, so I ask myself, what times what is -4? I can do -4 and +1. So I can do an x plus 1 and an x minus 4. Notice in this case, my x minus 4 and x minus 4 do cancel out. So when I'm finding my vertical asymptotes, I only do this x plus 1 because these blue things are holes. So my x plus 1 is my vertical asymptote. So I can say x plus 1 is equal to 0, and then I subtract 1. I say x is equal to -1 is the vertical asymptote. And I'll box that analysis. Yeah, close enough. All right, I move on to number 21. So let's do my horizontal asymptote first. Again, to find the horizontal asymptote, you take the limit of our function, h of x, as x approaches infinity. So again, top-bottom rule, so get rid of everything that's small there, and my coefficients, my powers here tie, so this is a magic fraction. Magic fraction, you take the coefficient of 3, take the coefficient of 1, make that as a fraction, and that's just 3. So you can say y equals 3 is the horizontal asymptote. Okay, one of the two analyses is done, and I move on to my vertical asymptotes. My vertical asymptotes, again, I need to factor everything to make sure I catch all the holes that might trick me into thinking they're vertical asymptotes. I can factor out a 3x in the numerator. What's left over is an x plus 2. In the denominator, I can see it's a difference of squares. It's a difference. This is a square. This is a square. So it's a difference of squares. So it's x plus 2 and x minus 2. And again, I can cross off the x plus 2's because those are my holes. That's a hole. Whenever the top and bottom cancel out, they're always holes. This is the only thing that's going to be the vertical asymptote. So my x minus 2, the denominator is set equal to 0. And you can say x is equal to 2 is the vertical asymptote. Thank you. All right, number 22. Again, starting out with our horizontal asymptotes. You have to say it over and over again. To find the horizontal asymptote, you take the limit of our function j of x as x approaches infinity. And when you do that, you scribble out all of the terms that are lower degrees, power 3, power of 2. 3 wins, therefore this is 0 in this case. So you can say y is equal to 0 is the horizontal asymptote. Okay, to find the vertical asymptotes, first we need a factor to make sure we exclude all the holes. So in the numerator, I can first factor out a 2. What's left over is an x squared minus 6x plus 5. In the denominator, I can first factor out an x. What's left over is an x squared minus 6x plus 5. And it's interesting, right? This term and this term are exactly the same. They're the same polynomial. I mean, you could factor it further. I hope students don't do this. What you should do right now is you should just cross those out and be like, that's a hole. Technically, there's 2 holes because, here, I'll write this in green because I don't want you to do this. You could write that this is 2 times x minus 5 and x minus 1. And this is x times x minus 5 and x minus 1. And you could cross them out here instead, but that's silly. Just cross it off right here. So essentially it boils down to just 2 over x. So x is the only thing that's not crossed off, so that's the vertical asymptote. And you don't even need to do any work, right? This is just x is equal to 0. So you can say that was a terrible S, is the vertical asymptote. Excellent. All right, moving on to our second last problem, number 23. I was worried that we had problems after that. All right, let's find the horizontal asymptote. Again, to find the horizontal asymptote, you take the limit of our function k of x in this case as x approaches infinity. So top bottom rules, I'm getting rid of all the smaller degrees, and power of 2 wins over the power of 1, so this is a does not exist. You have to interpret that though. You can say that there are no horizontal asymptotes in this problem. Okay, let's analyze the vertical asymptotes. First, we need to factor. So if I factor the top, it's still x squared plus 2. Can't do anything when there's a plus sign in a square. And then in the bottom, I can factor out a 3, I guess, x minus 3. And again, nothing crosses off, so I set 3 times x minus 3 equal to 0. Most students know you can do this, but let me just restate that you can divide by 3, and you get x minus 3 is equal to 0. If you add 3 on both sides, x is equal to a positive 3. So you can say x equals to 3 is the vertical asymptote. Excellent. All right, now our ultimate final problem. Let's first find the horizontal asymptotes. So the horizontal asymptotes, it's the limit of our function m of x in this case as x approaches infinity. All right, look at our top bottom rules. Get rid of the smaller powers, get rid of the smaller powers. It's a tie, x and x tie. You take the coefficients, positive 3 and positive 2. This is a positive 3 over positive 2, which means our y is equal to 3/2 is the horizontal asymptote. We approach this height of 1.5, aka 3/2. That's our magnet that we're not allowed to touch. All right, and then to find the vertical asymptote, we need to factor. You can't factor anything on the top. I guess the bottom you could factor. Here, 12 plus 3x all over 2 times x plus 4. You could factor it, sure, and you can say, okay, set that denominator, 2 times x plus 4. Set that denominator equal to 0. Divide both sides by 2, and x plus 4 is equal to 0. And then subtract the 4, and x is equal to -4. And that is the vertical asymptote. All right, that concludes our worksheet 1-3 for AP Calculus AB. Let's go ahead and see the entire backside. There it is. Let's look at the entire front side. There it is. Thanks for watching.